So we are going to learn complex numbers to help us simplify the solutions to quadratic equations. Complex numbers are used in a variety of applications, but this leads us into the next section where we will be solving quadratic equations and may not necessarily have a real number solution. The definition of a complex number is a plus bi, where a and b are contained in the real number system, and I is the square root of -1, and that's what we call the imaginary unit. I equals the square root of -1. So if we took both sides of that equation and squared it, that means I squared is -1. Then if we did I cubed, we'd have -1 times I. Since I squared is -1, so we would have negative square root of -1. Now I to the fourth is the same thing as saying I squared times I squared, which is -1 times -1, which is 1. Complex numbers add and subtract just like combining like terms. They work how you would want them to work. So if we were to subtract the complex number 2 plus 6i minus 7 plus 4i, we would have 2 minus 7 plus 6i minus 4i, which is -5 plus 2i. 5 minus 2i times 5 plus 2i, we're going to multiply like normal. This is what we would call a complex conjugate. Complex conjugate, if this is 5 minus 2i, its conjugate is 5 plus 2i. When we multiply complex conjugates, we actually get a real number. So let's multiply this out. 5 times 5 is 25. 5 times positive 2i is 10i. Negative 2i times 5 is negative 10i. And then negative 2i times positive 2i is minus 4i squared. Plus 10i minus 10i will cancel out. And then remember, I squared is -1. So -4 times -1 is 25 plus 4, which is 29. So when you multiply complex conjugates, you get a real number. So notice that 29 is prime in the real number system, but you can factor it into 5 minus 2i times 5 plus 2i in the complex number system. Okay, then let's simplify radicals with negatives under the square root. So the first thing that we would do is factor out the square root of -1. Have that times the square root of 162. Simplify the square root of 162 as you normally would. So by doing that, we look for perfect squares that are factors. And 81 is a perfect square factor of 162. The square root of 81 is 9. We have I from the square root of -1. That's the definition of the imaginary unit. And then we've got the square root of 2. As long as you don't put the I under the square root, it's common to see any of these. As long as you don't put the I under the square root, those are the same by the commutative property of multiplication.